Hello everyone, this is the final project of the ITCS655 Natural Language Processing subject. I'm Konati Klangtong, and today I will talk about my work, the Sentimental analysis from self-admitted Technical Debt Dataset using NLP. What we will talk about is separate into 5 categories. Start with motivation, and then research question, the experimental analysis, and end with the conclusion. My motivation for choosing this work is that I'm currently research on the technical debt, and I am doing the systematic review of the SATD identification and classification technique, and I have selected 27 paper for my work, but I have found a paper that outside of my study, and it's all about the sentimental analysis. So I'm asking myself, is sentimental analysis help with my work? So I have a chance to use this project to answer my question, and I will start with the background and related work. We'll start with technical debt. The technical debt is a metaphor, meaning that we should shortcut to do our work instead of do the proper work when we are programming. When you see the picture on the right, you can see that a guy is having a hard time choosing between working a new feature or refactor the old code. This is the trait of technical debt. To help us understand more about the technical debt or TD, we will use these two figures to explain. Start from the number one in the left. This is a chart to show that how much technical debt will cost us. In the nature, starting from the origin, the time is running in the x-axis and the cost in the y. The technical debt will increase the cost of the operation when time grow on, because if we do a bad work before, we will have additional work to fix it in the later time, and it tend to increase from time to time, and the increase part is called interest. That like we borrow the money from the bank or something like that, the interest is increased as time go by. And from other study, average 25% of effort is wasted on the technical debt. And this is the technical debt quadrant that separates the technical debt into the 4 types. And we will focus on the top part, is that the programmer know that he or she doing, but it itself has the 2 separate cases. It the reckless, meaning they have no choice, or it prudent, meaning the plan. In this quadrant, the self-admitted technical debt can be bought, because when planned, I just keep commenting to the code that okay, this is for now, we will deal with that later. And for the reckless case, it's like in the example, we don't have time for this, something like that, meaning it admitted that it is a problem for now, but we don't have any other solution yet. And the term self-admitted technical debt, or ATD, first introduced in 2014 by Podda and Shihab from a paper and exploratory study on self-admitted technical debt. They define as developer admit when they are coding some technical debt. And from that paper, Podda and Shihab used this approach to do the SATD identification. First, that they procure source code on the GitHub 10 project. It's all Java based. And then they use the tool to pass the comment. We got comment from this step. And then they will analyze that what comment are SATD and what's it not. And then they will classifying SATD into subtype. And 3 years later, Maldonado has improved that approach. He adds the manual classification into his approach, and he provides his work. He manually labeling 65,000 comments, and he and his team got the 4,071 comment as SATD. And this dataset has become the baseline for another SATD until now. This is a list of my work. More than half of my paper using the Maldonado dataset. And it's come to the research question. The paper I have using as the best paper has the second research question. He asks, how is the sentiment polarity distribute across SATD intonation? But he only using 25% of the dataset provided by Maldonado. So we will respect that question, and we will ask how it's distributed across using NLP technique, because the best paper they are doing the same manual labeling. And my hypothesis is that if there is no difference in distribution, it means the sentimental analysis will not help my work with the identification and classification at all. So start with the experimental setup. First, we have to acquire the dataset. So we go to the dataset that Maldonado and his team provide in the GitHub. We got the zip file, and inside the zip file, there is only one CSV file containing the 3 columns. We only use the 2 columns, which is the classification and the comment tag. And we only use the SATD comment is 4,071 and 5 type of SATD. For now, we got the data. We do the sentimental analysis. We use the NLTK library and the weighted sentimental analysis to help. And we will use Panda library to read the Excel file into the data frame. The reason that we have to use the Panda to read the XLSX file is that there are comments that span across the line, and if we do the modification to the CSV file, the comment will split into the multiple line, and we will have a hard time put it back into one line. So we decide to go with the XLSX file. And the characteristic of the comment is that they have some special character to indicate that this line is the comment. So we will have to remove that. And for the result, first we plot the sentimental. We use the compound. The compound is the summary of that. Each line is how much negative or positive with that. And you can see in the left figure. The left figure is how the sentimental span across. This is a positive, and this is a negative. And we can see that this is a triangle shape is mostly a neutral with a little span across negative and the positive. And when we group by the each SATD type, we can see that everything is mostly neutral with a little positive on this test. But it not matter much. If there are some distinction like this, the red bar in this maybe the sentimental analysis will help, but if it's like this, the sentimental is not help us at all. And when we got the result, we will do the comparison with the base paper. In the base paper, we focus on this part. They do manually label sentimental between 5 types of SATD, but the problem is they only use negative and the non-negative with some mix, and for the mixed one it's not really matter because of its small number. It means when we put in this word, the 299 is 30%. If we categorize our work into the 3 parts, in the neck, in the neutral, and in the pause, which means it spans nicely between 3 groups. But our results show that most of the sentimental using NLP technique is neutral. So this is a contradiction. But when we're looking at how it spans across their work, it does not really matter much because each of the type is around 30 to 40%, which means even the comment return the negative sentiment, it will not help with the identification at all. For the further analysis, I read the dataset manually too, and I have picked 3 comments to show my case. If the sentimental analysis have an impact, the comment may need to have some word like may not, I had to, no need, with its own negative. But generally, in the dataset, the comment is just simple sentence. Is that display warning? It have become a neutral because it did not show emotion at all. The algorithm is in opponent 2 is give no emotion. That's why the sentimental analysis is not helping us here. And for the conclusion, we can see that when the comments are mostly neutral, the sentimental analysis will not helping us at all. And that may be related because the comment is stay in the source code, and the source code is different between each programming stack. And the comment has no standard or practice for the programmer to use as the baseline. And the most useful thing I got from this project is that it helped me skip the sentimental analysis work out of my systematic review. And this is all for today. Thank you.